Hi everyone, this is a video explaining our final BE1500 project. My name is Vartka, by the way, and my other teammates, Ravina, Dominic, and I, chose the 2015 US Traffic Fatalities dataset. So, motorization has improved the lives of many human beings, and our society has improved so much because of it. But it's come with a price. Traffic fatalities are extremely significant because they take so many lives each year. In fact, the year of 2015 saw the largest percentage rise in motor vehicle deaths in the past 50 years. And according to NPR.org, 38,300 people were killed on U.S. roads and 4.4 million were seriously injured, meaning 2015 likely was the deadliest driving year since 2008. That is why, for our project, we decided to use this dataset, because we thought we could use this dataset and analyze trends and see how different variables affect the likelihood of a fatality. So, our project statement. Our project statement is to be able to determine the probability of a fatal collision based on 8 variables. There were many variables in our dataset, but the variables we chose to analyze are day of the week, time of collision, involvement of a distracted driver, involvement of a drowsy driver, blood alcohol concentration of driver, involvement of speeding, age of the driver, and state of US. So we totally have 5 function files that focus on these variables and output different visual representations of our data. The codes we've written are also very versatile because it allows the user to give many different types of inputs. And even though we have 8 variables, it is not necessary that the user input all 8 variables. They can omit any variables that they don't want to include. Splitting it up variable like this allows us to, analyze each variable and see which variable made the largest contributions to traffic fatality and help prevent them in the future. We also output a final probability that takes into account all the different probabilities from all our function files.
When we began our project, the first step was finding the right approach. We needed a process that would take one parent function as well as at least 3 function files that would work together to create a final output that gave the user valuable information about traffic fatalities. For the first one, distractions, the parameter we worked with was whether or not the user was distracted during the fatality. The outputs for this are the probability of a fatality with distractions, as well as a pie chart that shows the user what proportion of fatalities involved a distracted driver and what proportion didn't. The second function file was age. In this, the user inputted an age range, and the function outputs the probability of a fatality within that specific age range, as well as a pie chart that includes all the age ranges. The third one was general probability, which actually allows the user to input up to 5 things in a vector. And those parameters are time of day, day of week, speeding, whether or not the user was drowsy, as well as their blood alcohol content. And it outputs the probability of a fatality with these specific inputs. For example, if the user inputted daytime on a weekday when the driver was not drowsy but was speeding with a positive blood alcohol content, the function would find all of those rows in the Excel file which corresponded with that and calculate the total. Lastly, the states function also takes in the same type of user input, but instead outputs a vector with 56 elements, which determines the probability of a fatality based on the user input by each state. And it outputs another vector that is the probability of a fatality in general not based on user input, but also by state. Finally, our parent function takes these together and multiplies the probability of a fatality with distractions, age range, and user inputs to get a total probability based on all of these things. This function file calculates the general probability given a user input of a 5-element vector. So at first this may seem confusing, but in the Excel file, the different variables are given different numbers such as 1, 2, and 3, which mean different things. For example, in the Excel file, 1 for time of day means day, and 2 equals nighttime, 3 equals unknown. For day of week, 1 equals weekday, and 2 equals weekend, etc. Therefore, the user can input a vector with the parameters in this order of time of day, day of week, speeding, drowsy, and blood alcohol content, and input the appropriate number for whichever conditions they prefer. If they prefer not to include that condition or ignore it, they can input a 0, and the function will not take it into account. Next, the function reads the different columns of the Excel file that correspond with those parameters and saves them as variables. It also initializes a variable count1 and determines the length of the columns, which is the number of rows in the Excel file. This function is mainly centered around a for loop, which has a very long if statement, but what it essentially does is that if the user had inputted 0 for that variable, it ignores it, and if the user's input and the input in the Excel file match, it counts it towards the total. At the end, after it has summed up all the appropriate rows, it calculates the general probability by dividing by the total number of rows and displays that to the user. The next function file here takes the same input, but instead outputs this probability by state for that input, and also the total probability of a fatality by state, not based on the input. It does the same thing in terms of reading the Excel document, but instead of summing it up as a number, it sums it up in a vector of 56 elements that correspond with each state as defined by the Excel document. It uses the same type of for loop, but instead adds to each element in the vector by state. At the end, it divides each element in the vector by the total number of fatalities to get the probability of a traffic fatality in each state based on the restrictions set by the user, which is state prob, and also the total probability of a traffic fatality in general, which is total prob.
Part of the Excel file. In this function file, the variables used are the different columns that correspond with the age. You have the age for the age group from 15 to 19, 16 to 19, 15 to 20, 16 to 20, and 65 plus, 21 to 24, and 16 to 24. So what this does, it takes user input and it outputs the probability of being involved in a fatal accident based on the age group defined. For example, if we take the function header right here, press copy, paste, and replace type with the user defined variable, such as age 15 to 19, this function file will run and output a number between 0 and 1 of the chance of the user being involved in a fatal accident based on what age group they chose. Function file, it finds the probability of being in a fatal accident, whether the user is distracted or not. It follows the same format. The variables changed are distracted driver and driver not distracted, which corresponds with ones and twos in the Excel file. One meaning that there was a distracted driver involved in a fatal accident, and two meaning that the driver was not distracted in the fatal accident. To call the function file, all you have to do is, just like age, you can copy, paste, and replace this with, for example, driver not distracted, and it will come out with a probability or a number between 0 and 1 of being in a fatal car accident, depending on whether the user chose to define the driver as distracted or not. Inputs from all of the other different functions and outputs the overall probability of being involved in a fatal accident according to the user input. The user inputs their desired variables into type 1, and par, which go along with their respective function files in that order, and that all outputs a overall probability.